Okay, we're live on Facebook, and now I'm going to open up the webinar to folks. A minute.
Okay.
Matt, your dad texted and said, "Hello, son." Or not texted, he commented on Facebook.
Hello.
And Ryan, maybe Grindle, I think might be his last name, says, "Hey, Matt."
Oh, awesome. Hey, Ryan.
And Scott
What?
Blauis, I'm not sure how to say his last name.
That's my bro.
Oh, great.
My sister's husband.
Okay. Okay. Well, let's see. Maybe we'll give folks one more minute to come on in, and then we'll get started.
Should we have like some intro music or something?
Well, let's just get started. Folks will roll in, and the beginning is just me, so they won't miss you. Okay, welcome everybody to our talk with Matt Primomo tonight. We're very excited to have him and appreciate you all tuning in to watch and listen to what he has to share. I'm going to start the evening by reading a land acknowledgement that Wenatchee River Institute put together with the Piscosauga or Wenatchee people. So the land Wenatchee River Institute sits on is the ancestral homelands of the Shimpishquashu, Piscosauga, or Wenatchee people. The Shimpishquashu, meaning people in between, had villages positioned along the Wenatchee River. Their ancestral homeland extends from the Cascade Ridge throughout what is now known as the Wenatchee and Okanagan Valleys. The culture and economy of the Piscosauga people centered on fishing. They also gathered roots and berries, basket-making materials, and medicines. They also hunted game. The Piscosauga are named within the Yakima Treaty of 1855. Language to establish the Wenatchee Reservation was never followed through, even with the needed surveying completed. Many Piscosauga now live on the Colville Reservation, 150 miles northeast of Leavenworth. The Piscosauga people are still alive today. They continue to practice their culture within their homelands and are working to get land back within their ancestral homelands. The Piscosauga people are the original stewards of this land, and we offer this land acknowledgement as the first step to amplifying Indigenous voices and recognizing the harm done to them as a people. We encourage all of you to learn more about the Indigenous peoples of the place you now call home. So welcome everybody. My name is Rachel Bishop. I'm the Community Programs Manager at Wenatchee River Institute, and we are an environmental learning center in Leavenworth, Washington. And our mission is to connect people, communities, and the natural world. And we do that primarily through two different types of programming. We have youth programs and community programs. And I'll just give a brief intro of what each of those are. But for our youth programs, we offer day camps for kids 2 days a week. We're working on putting together our summer camps. We work in the Wenatchee School District after school program. And we also are starting to do in-person field days with schools in the coming months, which is exciting. And for our community programs, right now, registration is live for our annual Spring Bird Fest, which is May 13th through 16th this year. We're doing virtual speaker events such as this, and we have more coming. We are also starting to have in-person outside classes, and just 3 upcoming things I wanted to mention. tomorrow night, we actually have a virtual storytelling event with 8 different storytellers from our community, and that's virtual at 6:30 tomorrow. And then next week on April 22nd, Earth Day river cleanup from 4 to 6 p.m. We're going to be walking along the Wenatchee River in downtown Leavenworth, cleaning up. And on April 27th, we are participating in the Wenatchee Valley Museum and Cultural Center's environmental film series. And we are showing the film called Promised Land. And it highlights 2 tribes on the west side, the Duwamish and Chinook. And it's about tribal sovereignty and gaining their rights back that were promised in treaties. But on the 27th, after folks have had a chance to watch that film, we have 4 folks who are joining a panel discussion to learn more about the Pasquosa and Wenatchee people and what they are doing in terms of fighting for certain rights that they should have been given as a people. So if you want to sign up for that, you have to go to the museum's website to register, and you'll get the link to watch the film and the link to watch the panel. And so I'm gonna introduce Matt here in a second, but if you're watching through Facebook, you can ask questions in the comments. And then if you're watching in the Zoom webinar, you can ask questions through the chat or the Q&A feature. And we will have questions answered at the end of Matt's presentation. And as always, I appreciate everybody's patience with any technological issues that happen. It's what comes with the virtual atmosphere that we are all in. And make sure your sound is up because Matt has some videos that he's going to be showing. Okay, now I'm going to introduce Matt. And Matt is a friend of mine, so just personally, I would like to thank Matt for doing this. And I appreciate Matt as a community member in the Leavenworth and Wenatchee communities. And I also appreciate how seriously he takes his job with the Northwest Avalanche Center. And as a backcountry skier, I love reading his forecasts and look forward to reading them. So Matt Primomo is an avalanche specialist who has worked at Northwest Avalanche Center since the winter of 2017-2018. Matt lives in Leavenworth and is responsible for writing the avalanche advisories for the East Central, East North, and Stevens Pass zones. Matt is intrigued by snow and its unique properties. He enjoys tracking the ever-changing snowpack, winter weather patterns, large avalanche cycles, weather station maintenance, and writing and teaching all about it. Previously, he spent 5 years working as a year-round avalanche professional, maximizing his time spent in winter. Matt worked with the Utah Department of Transportation as an avalanche forecaster, while also directing an avalanche program for a small gold mine in Chile during the Southern Hemisphere winter. Matt is a certified ski guide with the American Mountain Guide Association and a pro instructor with the American Institute of Avalanche Research and Education. He holds a bachelor's degree in geography from the University of Colorado and an associate's degree in outdoor recreation leadership from Colorado Mountain School. In the summer, he works as a mountain guide with the Northwest Mountain School and Exum Mountain Guides. When he isn't working, you'll find him enjoying the mountains with his wife, climbing, surfing, working on the house, sharpening snow saws for his company, Primo, Snow and Avalanche, or attempting to cook Italian food as well as the rest of his family. So Matt, I'll turn it over to you now, and thank you again so much.
Awesome. Thanks so much, Rachel. That was a really nice intro. And recognizing the native peoples of the land where we live, I think is really important. So I enjoyed that. Yeah, so thanks so much. I'm honored to be here and honored to share the story of our winter snowpack and some important avalanche events that we had. So I'll just go ahead and jump right into it here. Gotta do a share screen. All right. So yeah, I just called this the winter of 2021 in the Central Cascades, because that's where I live and where I'm working and out of and forecasting for with the Northwest Avalanche Center. So that's that's where my experience comes from during this season, but we have photos from kind of all over the place. So we'll just start from the beginning here. What is an avalanche? Well, an avalanche is just basically a mass of snow moving downhill. They can be dry and wet, dry or wet, sorry, and they can be slabs, a big wide mass of snow that comes down like this one in the video here, or they can be loose snow. So this is a video from avalanche control work that they did on Snoqualmie Pass on I-90 on February 24th. So I'll jump into the avalanche danger scale. This is what we use as a public avalanche forecaster. This is what I use to help communicate the avalanche danger that we expect you may find for the following day. We put our avalanche forecast out at 6 p.m. and we do an avalanche rating for 3 different elevation bands in the terrain, the alpine zone, the high alpine without trees, the middle ground where the trees are kind of like crumholts, the near tree line band is what we call that, and then below tree line. So we put this avalanche danger forecast out for 3 different elevation bands throughout the terrain each day for all of our different zones. And we've got a whole bunch of different zones in Washington. So the North American Public Avalanche Danger Scale, what it does, it tries to take into account the likelihood of avalanches and pair that with in conjunction with the avalanche size and distribution to give you an overall travel advice on how to treat the day and how to go about staying safe if you choose to go recreate in the mountains that day. So most of the time, the avalanche danger is kind of floating somewhere between low, moderate, and considerable. However, once in a while, it jumps up to high, where we're seeing natural avalanches happen, maybe all over the place, and some of them may be very large. And then every other so often, not every other year, but maybe once every 5 years, or it could be twice in a year if it's a really wild year, we get to an extreme. And then there's the no rating, which is down here. And it's just something that we developed where we don't have enough information to give an actual avalanche danger, but we're still going to give information when we can. Okay, so we'll start from the beginning here. I'm going to show you guys some graphs and kind of walk through some of the season this way. And these are from the Schmidt House site at Stevens Pass at 3,950 feet, and also the Skyline site and the Brooks precipitation site, which is at 4,800 feet. Can you guys see my cursor there? So this is the snow depth on the ground through time in inches. So the bar there is on the left in inches. Here's the temperature trends each day through time at both different sites there. And then we've got the precipitation coming in down here in the bottom. And this is in inches as well. So our season started early. I was out skiing in October this year. Actually skied up on Stevens Pass at some point in October. And yeah, it was pretty fabulous. And come November, we were off and running. I think we started putting out our forecasts right around the 11th or so of November. So we had a good early start, had like 50 inches on the ground, starting in mid-November. All right, and then December came in, and Um, Things, it didn't really start snowing, it didn't really pick up again until around the 17th. But then we got a few storms. You can see the precipitation down here. And then the temperature regime, if you look at that, it warmed up a little bit. And we definitely got some rain. Oh, yeah, actually, this part right here, around the 7th and 8th of December, we had really warm temperatures and we had precipitation. So, along with that, rain came to the tops of the mountains. So the skiing kind of got really bad for a little while. Uh, Eventually, the snowpack froze. You can see the temperatures drop down here. And so that's a theme that I'll be talking about a couple different times through the season. But this is the first high elevation rain event that we had that was really memorable for the season. So we had crust just all over the place, no powder snow anymore, cold temperatures, and what normally happens when you have a number of days of cold temperatures is you get weak snow on the surface. The snow, if there is any loose snow on the surface, it becomes weak over time, and maybe granular and what we call faceted. And so right around that December 13th timeframe, we had our first layer of what we could call a persistent weak layer, where a really weak sugary layer over a crust formed. And then moving into the middle of the month, around the 15th, 17th, 19th and 20th, that was when we had some snow building up on that layer. And come early January, we had a really big storm that finally overloaded some of that layer. So these photos here are from Washington Pass. And you can see this is looking down at Highway 20, and it just got buried. We had a really widespread avalanche cycle in early January. You can see the avalanche debris crossed well over the road and even, broke some trees down below the road and pushed them over. So all the path runout zones are along the highway here. You can kind of see them from a distance. Here's the crown of a fairly deep slab avalanche that pulled out in one of the paths across the creek from Highway 20 over towards Silver Star. I guess it's kind of like the backside of Kangaroo. And then there's Harlan Shepard, one of the avalanche forecasters for the DOT, riding a snowmobile over this debris pile above the hairpin in the Liberty Bell paths. We went up there one day to work on the weather station during a brief clearing in the weather in late January. And so that avalanche cycle we had in early January, it made some really big ones, kind of all over the place. Up north, along the Highway 20 area, it was like I showed, it was a really widespread cycle. And down here, this is the Wellington slide path. Josh Herfberg, my colleague at NWAC, standing in one of the gouging debris piles. So this is the site of the old Wellington disaster that killed like 96 people. And, we did have good weather in the middle of January. We had a decent amount of snow on the ground. Unfortunately, the snow that was there just wasn't very good. It had rained to high elevation with this atmospheric river event and created avalanches on that previous crust that formed in early December. And you can see crowns. Does anybody know what feature this is? Kolchak Glacier. And then there's Kolchak Peak right there. Nice, I see somebody got it. So, traveling around in the middle of January became relatively safe. You couldn't make an avalanche at a certain point there because the snowpack was just so frozen, locked up. It had rained to 8,000 feet in elevation, but things had just kind of melted down. And even like this photo here is from 8 Mile Creek, where so avalanche is running on the ground, and things just didn't look very good. Like things were in rough shape. And so that began what I'm going to call the January drought. So here's that atmospheric river event that we had right around the 11th through 13th of January, and really warm temperatures you can see along with that. And, slowly the temperatures drop off and get colder and colder. And we don't get any, hardly any precipitation during that time. There were a couple of small storms in there for areas near the crest, but, for the most part, it was just dry, dry, dry. Cold temperatures down here around towards the end of the month, like the 26th or so, was quite cold. And I think it was the 22nd, I got out on a day with some other friends and skied Buck Mountain. And we got up into the high mountains, and it's like 8,000 feet. The skiing was not very good, but we were looking for good snow. And it was a pretty interesting time to get out there and see what was out there on the surface, because everything had become recrystallized, and we just realized there's like a lot of really weak snow out there and over this crust, and it's everywhere. And so eventually, we started getting more snow towards the very end of January. And so this is that day that I was speaking about up on Buck Mountain. I think this is like a southeast facing slope up near 8,000 feet. And you see the way the snow just looks crystallized, and you can see like little chunks of snow are just sliding down this crust. There's just no resistance. So a lot of really weak snow surfaces out there, and faceted, when you see stuff just sliding along like that and just not stopping. It was a fairly steep slope, but, to see that happening is usually pretty telling from my standpoint. And then other surfaces out there looked like this during that time of the January drought. We had like a freezing rain crust in places. It was just translucent, kind of nasty. Other places, just a bit of a rain crust, and you can see like some chained up facets where they're actually, growing in chains underneath that. And then here's a photo of what some of the grains looked like in some places. Overall, the layer itself had some facets, and they were weak, but they were not really large facets in a lot of places. They were just kind of medium sized. Having trouble with my clicker. And then by the end of January, what happened was the jet stream dropped south, and storms started to circle in, and California actually started to get slammed by storms. And what that does for the east slopes, like especially areas like the eastern Wenatchee Range and Mission Ridge, is storms will come up and circle around, curl around as the low pressure systems come through counterclockwise, and tend to hit the Mission Ridge area really well. And so that's what happened. Mission Ridge got like somewhere between 2 and 4 feet just in like a number, maybe a week worth of time of similar pattern storms just rolling through one after another. So Mission Ridge got out there and did control basically for the first time in the season. They didn't need to do it previously, and they were getting these really widely propagating avalanches on this crust layer. And one of the patrollers, or a couple of the patrollers, reported echoing collapses. So the snowpack was collapsing, and they reported really, really wide and kind of scary collapsing. So that was just kind of a precursor of what was to come in February. So February is, where I'm going to spend most of the time in the rest of this talk, and that's where things got interesting, and it was just one to remember for a number of reasons. So this is when snowfall began in earnest up on the crest, up at Stevens Pass, up on the passes of the Cascade Crest. So for a time there, we actually had more new snow coming in the Wenatchee Range, which was a little bit different. And we saw this weak layer that formed in middle of January begin to act up there first. And then, as the storms began to roll in over the crest, we could go out and find this layer and, quickly realize it's going to be a problem. How much of a problem, we weren't really sure. So there's me skiing along in the Icicle Creek somewhere in early February, and we were getting these really giant whoops or collapses only in areas that were like thickly wind drifted. So there was just enough new snow in those areas where you could collapse the layer, and the collapses we're getting were, you know, very substantial, really notable. So the other thing about the month of February is that unfortunately it was a really tragic month throughout the USA for avalanches. We had more fatalities in the US in any 8-day period since the Wellington disaster in 1910. So yeah, in 8 days we had 16 people die in avalanches. And I've talked to other avalanche professionals about the death spiral thing. It actually comes from an older forecaster that I used to work with in Utah. He called it that. And basically what it is when you see fatalities happening in surrounding states, you know, pay attention to that, because eventually, you know, the conditions are probably going to be similar enough, and eventually you start to get fatalities near home. So that's kind of exactly what happened. You know, it spiraled around from Utah, Colorado, Alaska, California. Eventually, we had our first fatality, unfortunately, in the Salmon Lasac area. So one thing to look at with the avalanche danger scale, it's kind of interesting that I stumbled across recently, is this odds of triggering, which is this came from a paper from some of the best avalanche professionals in the business, Bruce Jameson, Jörg Schweitzer, and Cora Shea. And it was a survey, like a formal survey to other avalanche professionals out there on what they thought the odds of triggering an avalanche was for specific danger level. And so you can see as we get to considerable, your odds of triggering an avalanche are somewhere between 1 in 100 and somewhere in 1 in 1,000. Obviously, it could be less or more depending on the situation, but this just gives you an idea. When you get to high danger, your odds are pretty darn good. And, you know, if you're out there skiing steep slopes or snowmobiling on steep slopes, you're probably going to trigger some avalanches. So on February 7th, the day before that fatality, we had raised the avalanche danger to high across the board. And these guys went and they were skiing in the Jim Hill area. You know, the temperatures were staying cool. I think this guy he knew the zone. There were a couple parties in there, and unfortunately, they released an avalanche on the second lap. So they had skied in there. They had put a skin track in. They had made a ski descent without anything happening. Another party came in, followed the track. They were up there at the top, I think, getting ready to ski, while the first party was coming back up their own track. And at that point, the avalanche released. They were able to grab onto trees and let the debris flow underneath them. And other folks, the other party was at the very top of the crown, and maybe got pushed over a little bit, but they got really lucky. They weren't buried. And, you know, this was a multiple person, very close call. And, you know, there were a number of accidents this year with multiple people involved. And so it seems like a trend that we're starting to see is multiple party accidents, unfortunately, seem to be happening more and more. This is just a before and after picture on the left and right to show you what that Jim Hill area looks like right about now, after the big avalanche cycle we had around February 22nd. So you can see some trees are missing. So a little bit more about that Knox Creek accident. There were 2 snowbikers involved. They came across the slope here. You can see if you look really closely, there's parallel tracks. They were riding along. And, you know, there's definitely some steep slopes above them, but they were coming right from some clear cuts, kind of low angle slopes. But unfortunately, they cut into this one at the wrong time and triggered the slope. It was a really large crown. And yeah, it got to be about 6 feet deep in the deepest spots, ran all the way across the base of the cliffs. And unfortunately, one person was buried and killed, and he did have an airbag pack inflated, which was uh, pretty wild. It was just a really big, deep avalanche. So that was a really sad day for the community. So this is a powder cloud from a natural release over Highway 20 sometime in the middle of February. These guys just happened to be there. The winds were ripping and the thing avalanched and they caught it on film. So pretty wild. Yeah, so during the middle of February, we had a lot of snow. It kept piling up. We were seeing avalanches on that persistent weak layer from the middle of January kind of taper off. Temperatures got really cold, and this is just what a typical snow profile may have looked like around that time in the middle of February, where you have anywhere between like 3 and 6 feet over this crust with weak snow above it, maybe weak snow underneath it, like in this case. This is the crown from that Knox Creek fatality. Fairly similar, although a lot more snow over it. And you can see the old discolored snow underneath there. So February 13th is notable because we had a really big storm in Seattle. For the folks that live out there in the metro area, they got like a foot or so, maybe more in parts of the metro area. And it was really, in the mountains, it was really cold, dry snow. For it to snow down there at sea level, in the mountains, it's going to be really cold, dry snow. So we had goose feathers out there, and this was like a week after most of the events on that persistent weak layer we had, and we kind of stopped seeing avalanches on that layer. It seemed like things were just hanging in there. Most folks were in the trees, however. We didn't have a whole lot of high pressure, not a lot of good weather to get out there in the high mountains, and most folks were just hunkering down in the trees and skiing. Really good cold, dry powder in old growth trees and kind of staying out of avalanche danger for the most part. The skies cleared around the 16th after a heavy snowfall event, and Josh Hertzberg, I think, snapped this photo, or maybe it was Will Govis, snapped this photo of Mount McCausland. And we're scratching our heads like, wow, that's a really wide avalanche. And it doesn't look that deep, but I don't know, is it the mid-January week layer? We weren't really sure. We kind of suspected it may be, maybe not. We weren't really sure, but it had been some time since we saw that layer act up, and it seemed like folks were starting to even step out a little bit. The thing with a persistent layer or deep persistent slab is that eventually they become difficult to manage. What a deep persistent avalanche is it when you have a deeply buried persistent weak layer, has to be at least 3 feet deep is kind of what our guidelines are. And it becomes less predictable and less frequent. So we don't see, like, we often, during a storm, you may see like a random avalanche here or there on it, but it's not like, clockwork, and it's maybe more difficult to trigger. So they can cause really large and destructive avalanches, some of the biggest ones that we know of. And, they're tricky to assess because they get deeper to dig down to that weak layer. The weak layer is becoming like kind of unwieldy to dig down to. Is like 8 to 10 feet deep. And it's like, we're digging down there and looking at it, but if there's that much snow on it, is it really going to be a problem? That's the question. So with these things out there, the terrain choices become kind of key. If you think it might be an avalanche whatsoever, you just need to dig well out of avalanche terrain and well away from the runout zones where these things can happen. It's just kind of a crapshoot. So Yeah, what we realized is, you know, keep doing snowpack tests. Any slight changes, such as moderate snowfall, direct sun and warming can start to make changes in that slab, which therefore can create avalanches. We're here at 4,000 feet on a northwest aspect on the east side of Stevens Pass, below Arrowhead Peak, targeting a zone with a more shallow snowpack. Finding the mid-January crust to be only about 1 meter deep here, so fairly shallow compared to other places in the zone. And it's collapsing on compression tests. So we're going to do a propagation saw test to see if it has potential to propagate. We're here at 4,000 feet on a and it sure does. So as a 25 out of 100, it propagated to the end. So with more loading, heavy wet snow on top, we're definitely going to be concerned about this layer for the next few days. So I think the sound is a little messed up on that, but hopefully you got the idea. So we were out there pretty low in elevation on February 20th. And this was just as the temperatures began to warm up a little bit. We had gone through the coldest temperatures of the year, maybe around the 15th or so. And then we began a slow warming trend in temperatures. And you can see that here on the graph. Oh yeah, I guess it was like the 13th, the coldest days of the year of February, where we hit 0 degrees Fahrenheit at some sites. And then if you look at the temperature trend here, it slowly rises up to freezing level. And then, February 21st and 22nd is when we had the really big storm that created a large avalanche cycle. So, right around that 20th time frame was when things started to get a little bit weird. And that propagation saw test that I did, we'd been doing those all through the month. And they're a great test to check out layers like this because you can compare test after test. And we were getting scores somewhere. So the way you score it is you got this column, you run the snow saw up through the column, through the weak layer, and whatever length the saw is at when the fracture runs and propagates to the end of the column is the score, and then the column length is the second part of the score. So we were getting test scores in like the 40 out of 100 range most of the month. But that day that I showed the video from, I got a 25 out of 100. So it was a much lower cut length. And that made me scratch my head and I was like, this is interesting. And the snow just feels a little bit warmer. Things are starting to change a little bit. And lo and behold, later that day, we get some information that a skier triggered an avalanche right near Skyline on this really steep slope here. And we were able to get a good look at it through a drone. Harlan and the DOT had a drone, he flew up there and you could tell through the discoloration in the bed surface there that it ran on the crust. And it actually broke some mature trees down to the bottom. So we don't really know the full story with this. It looked like the skier had entered the slope, triggered it. It ran. I think they somehow didn't get caught, maybe skied off the edge or maybe weren't involved at all. But it was definitely an interesting situation. And then the same day, like 46 miles apart in the Wenatchee Range, some snowmobilers triggered a slab and it scared the bejesus out of them here. And that slab was probably about 3 feet deep and didn't really know for sure, but it, definitely looked like it could be that mid-January crust layer that we were thinking about. So to have two, human triggered avalanches on this layer, well over a month after it got buried and after it had been dormant for like well over a week, more or less, was pretty notable. It kind of just started to wake up.
Hey, this is Josh Hirschberg with the Northwest Avalanche Center. We're out doing field work on the Stevens Pass zone, and we were out here to gather some information today, but because it's also high danger and avalanche warning, our goal was to avoid avalanche terrain. So we're sticking to these open meadows and low angle trees in a way that we can travel through the mountains, but still avoid avalanche terrain. It's important to note that we're also seeing more dangerous conditions than we typically see. So pay attention to the daily forecast and enjoy the backcountry and stay safe.
So there's Josh talking about, how to stay out of harm's way on a high avalanche danger day. And that store that day on the 21st was real high avalanche danger. There could be really large avalanches triggered all over the place. But the next day, we were even looking at, higher than that because the storm just kept coming. Here's a video from a couple of friends. They were out in the Eniat range where it had snowed less on that day of the 21st, and they were taking a look at the same layer.
Look at that. So it did do a clean planar release. 125, but overall ECTX, right?
Do you want to pull it out of
Per
the way?
hand. Yeah.
You want to make it go?
So sometimes certain tests like this extended column test,
That's massive.
wailing on the top, it's just not enough to test the layer very well. And that was kind of the case on that day there. But the important part is they sent me that video and, they were able to pry it off. And knowing about the storm that was coming, I was like, well, Anthony's pry is probably about equal to the load that we're about to get with this atmospheric river. We're about to get like 3.5 inches of water weight with heavy, heavy winds, strong winds, and warming temperatures. Maybe it's about equal to Anthony there. And so this is some satellite imagery showing the total precipitable water during that time. And this is, you can see the plume of the atmospheric river, which is just a narrow band of high volume moisture content that comes with high velocity winds. So the stronger the winds, the more the wind can carry the moisture in, and the higher the moisture content, the wetter it's going to be. And so this wasn't like a historic atmospheric river by any part. I think it was like, through the atmospheric river scale, it only classified as like a weak to maybe a moderate atmospheric river. But it was a big storm for the mountains at that time. And especially for the snowpack that we had, this was like, okay, now we're talking about our slabs are going to be anywhere from 5 to 10 feet deep. And based on what we know on the weak layer, this is going to be throughout the terrain in many different mountainous areas, anywhere basically above like 4,500 feet. We were worried about this layer waking up and slabs come crashing down, and that could be 10 feet deep. I was like, that's not a usual circumstance. An old consultant that I worked with previously down in Chile told me when they were doing modeling for the safety of the mining camp that I was working at, that they used a 2-meter deep slab to check the extreme runout zone for the camp to make sure the camp was safe. So they used a modeling program and basically ran a 2-meter deep slab through this avalanche path to see where it would go to. And I'm thinking to myself, well, the slabs we have now are deeper than 2 meters, and they're going to be everywhere. So here's a little bit of the forecast discussion. Basically the storm was coming in with a slow warming trend. It was supposed to warm up with the freezing levels reaching somewhere around 4,500 feet, which isn't that warm, but it's, coming out of the cold temperatures we had, it was just warm enough is what we thought. So we had 87 inches since the 12th of February at that site. And this time is going to finally start to warm up and, maybe even get a little bit of rain up high. So we were worried about, big destructive avalanches, trees getting ripped out, things like that, avalanches happening where they don't normally happen. And here's a look at the radar from early in the morning on the 22nd. So there's Stevens Pass right in there. So it's just heavy, continuous precipitation. It just kept coming. And this wasn't even like the heaviest part. I actually didn't capture that, but I call it the hammer, when everything was pretty much just yellow for like 4 hours. And, you know, the guys on the DOT, they were just trying to keep the road open since early morning. They had a really long day, and avalanches just kept coming down, and they were pulling out really big ones with control work. The slide path called Main Gainer ran, and that hadn't run since 2008. So the upper left photo is a photo that I got from them from 2008 when it covered the Highway 2 there. And then up on the right is the event that we had on the 22nd of this year. And the bottom photos are from this year as well. So it didn't actually hit the road, but it did knock some trees over that they had to cut out so you could get by. So the avalanche destruction scale, this is what I'm going to talk about next. How big were the avalanches that we were actually seeing? Well, they were in the D3 and D4 size range. And we saw quite a few of them, like kind of widespread all over the place, you know, mountains all over. Within the Stevens Pass zone and the East Central zone, we're running as D3s and D4s. So they could destroy, you know, several buildings if the buildings were in the wrong spot, or substantial amount of forest, and lots of mass along with those. Okay, so on the 23rd, it went blue. The skies cleared up. I got out there and just looked around with a friend, and we were just like trying to document like what happened. It was kind of difficult to see in a lot of places because it did keep snowing after the warm up, but so you could definitely see crowns all over the place. Debris piles, you know, had come across roads. This is an Icicle Creek going towards Dr. Creek there. Really wide crowns from avalanches that just ran thousands of feet across the entire ridges and mountaintops. And, you know, we're just seeing full avalanche path events, like things that don't run that frequently. So I rode up on the snowmobile up to 8 Mile Trailhead to have a look around. And I see through the trees, a really big debris pile, and I just walk up there, have a look at it. And, you know, there's trees that are like 12 to 14 inch diameter, just all over the place. There's an old burn zone up there, and it definitely widened the path pretty substantially. And this path runs about 4,000 vertical feet. And I was calling that a D4 just because of the amount of mass that came down and the amount of trees that came down with it. And then, you know, later on, we got to look into 8 Mile Creek from different angles. And you can see, here's the crown of an avalanche there. Here's the crown of an avalanche here. This is, you know, well after the fact, but you can just make out these old, deeper crowns. And then as folks got into the mountains, you know, later, when the weather kind of got up and things became safer, you know, we realized we're still kind of realizing the magnitude of this cycle was pretty substantial. Just lots and lots of broken trees all over the place, you know, D3.5s, like from many paths. I was up in the Salmon-Lasac area in March, and this cabin here, right off the road, the snowmobile road up in the Salmon-Lasac, it nearly got destroyed. And I'm not sure exactly how close the debris came, but there's a creek there that got filled up. And, you know, you can see debris down there too. I didn't actually go look at it, but I say it was 3 degrees from destruction, because I think if it had been 3 degrees colder, what happens with these really big avalanches is the temperatures were fairly warm, like this river bottom valley is like 3,500 feet. So that was all rain down there. And what happens with the wet snow is it doesn't move as fast. It starts to slow down. The really wet snow doesn't spread out as much. But if it were just a little bit colder, it may have been just a little more dry, and we would have maybe gotten more of a powder cloud with it, and the debris spreads out more and can be actually more destructive or can cover more area, and that powder blast along with it can be highly destructive along with just the debris. So I think if it was just a little bit colder, these trees and the cabin may have just been gone. So they got really lucky there. All right, so to try to dig in, like, well, how significant was it? How historic what was this avalanche cycle we had? It's necessary to look back at the known avalanche path that we have and the older history that we have, which, for our area, it's on the DOT Avalanche Atlas. So the main gainer, that path has run a number of times in the past, 100 years, but not all that frequently. The most recent occurrence was in 2008. And then the West Camp path off Rock Mountain there, that had last run in 1993, that large. And actually, no, not quite that large. They did control work and brought it down. But Mike Stanford said that it wasn't as large as it ran this year. It ran larger. So pretty interesting. Here's a look at that West Camp path. And this was one that it ran, I think it was on the 26th. It was after that event on the 22nd. So we got more, we had another storm and really, really strong winds. And what happened with this layer was, whatever hadn't run was kind of just sitting there, is basically kind of teetering in the balance. I call it the load limit. Like the slabs over this weak layer, like they were kind of just sitting there at the load limit. And so another storm with a lot of wind, some loading, and this thing ripped out. So this was one of the larger patches that I know from this cycle so far. And, talking about the colder temperatures for that cabin, we did have colder temperatures during this event. And so you get to see like what can actually happen. So I think that did play a role in, the size of the debris pile. Plus we had more snow in the path because it didn't run previously. But the air blast along with this slide was really notable. It knocked down a bunch of power lines, and they ended up having to do heli control to pull out some of the hang fire to make it a safe area for the workers to go in and get those power lines back up. So here's a video of that.
There it is. There she goes.
Look at that shit.
Look at that.
Huh? Holy cow.
It was pretty wild to talk about this being paint fire.
It's gonna get dusty right here.
Look at it boiling up. It's already down to the road.
How cool
So
is
here's
that?
some other photos from that path. You can see the power lines kind of just, draped across this tree over there. But yeah, mature trees are basically, I'm not sure how old these trees were. It's something we can look at later, but they were, a lot of them were just snapped. Look at it, airman bitching. Sorry, guys. Cool, but yeah, quite a bit of destruction. This is a very large slide. Yeah, the air blast alone took out so many trees. It's just amazing. And then here's another one that I went and had a look at. Anybody have a guess on where this one is? Here's a hint. There's a lake down there. Lake Wenatchee. Dirty Face. Yeah, so this one came off Dirty Face. I followed the debris down and, just tried to map where it was and about how high the debris was. And, it was average like 3 to 4 meters deep. And I ended up doing like a mass calculation on it. And I think I ended up somewhere around like 40,000 tons of debris. And it came right near a water tower. Luckily, it just kind of slid right by it. So other things that we can look at to try to get an idea of avalanche size or like timescales are, vegetation damage. Things like this tilting, call this tilting, when all the trees are just bent over and maybe kind of rake through from the debris flowing over it. And so once you get an idea of what that looks like, you can kind of look at these avalanche paths here and you're like, all right, well, something definitely ran through there. You can see an old crown up there as well. So other types of damage that we've been seeing is uprooting, where trees were just wholly uprooted and ripped out of the ground. Pretty wild. There's places where many avalanche paths, like the trim lines, were widened. Trees were stripped down, and I'm sure it didn't look like that before this event. It was probably much thicker trees. So here's a comparison that I was able to do through a friend's photo and one of my own photos of before and after. So I tried to make the circle right in about the same spot, and you can see some of that tilting and just stripping, and just trees are just kind of disturbed. That path certainly got a lot bigger. Some of the paths on the south side of Highway 2 that run over the old highway, these things got really big. And obviously, these things have run this big before at some point. But a lot of the newer growth trees, smaller trees kind of got ripped out of there. And here's a Wellington path on the right. So that thing ran really large. The train trestle there, I'm not sure how tall that thing is, but it's like probably 15 feet tall for scale. And the crown that was in that one ran all the way across the top of it. I was up in Surprise Lake just recently, and I saw some of that tilting. And actually, the tilting was down here on this lower berm. And, all these trees look kind of haggard. And, the slope was basically just filled in with snow. And I was kind of asking myself, well, what did that look like before? And I was able to pull up this satellite image from Google Earth in 2019. And here's that same area. So here's the path, the top of the mountain up here. The path runs down, and it shows pretty thick trees in that zone, which is right in here in the runout zone. So I think this one took quite a few trees out. Cool. So another way we can look at it is through the snow depth climatology. So NWAC has a really cool new feature on their website, and you can look at how deep the snowpack has been through time. And so for Mission Ridge over on the right here, things are right about average this over there. And for Stevens Pass, we jumped up quite a bit to like 140% of average of snowpack depth for a little while there. And then doing a kind of a random comparison of like some of the deeper snow years, I got interested in this. Like, all right, so the really deep snow years that we have, does it mean we have big avalanches? And the answer is no, not necessarily. We're not necessarily going to have really big avalanche just because we have a lot of snow on the ground. However, it does stack the cards in the favor of that. And the years in yellow are the years where we have records for one of those two avalanche paths on Highway 2 running down and hitting the road. So either Main Gainer or the West Camp path. And so those are, they're up there in some of the deeper snowpack years that we have. And then this year we ended up getting up to like 151 inches. The data points here are just 15 days apart. And so we kind of missed that in there, but, it was right in there with, probably one of the top 10% deeper snowpacks. we've had. And then this is, I kind of got a kick out of this. Those guys on the DOT, they've got this snow stake there at the Schmidt House study site, and above 13 feet, it's say your prayers, amen, is what it says on there, because they know what that deep snowpack means. So, the deep persistent slab continued, and as the storms kind of tapered off, the activity along with it began to taper off, but not completely. We still saw some really big and notable avalanches, and right around on March 1st, there was a busy weekend up there at Snoqualmie Pass. Folks were in this terrain on Saturday and Sunday, doing avalanche courses, recreating. People are all over the place in this terrain. And then Sunday night, it snowed a little bit, maybe blew a little bit. Not a substantial storm by any means, but this slab in the weak layer was kind of still sitting right near its load limit. And something happened. Maybe a cornice broke off. Not really sure, but it avalanched. It went really big. It was probably one of the deeper slabs that I've ever seen. Maybe 15 feet deep in places. So that was, for a lot of people, kind of a wake-up call. Like, yeah, these things are still very real, and the travel techniques are the most important way to stay out. You just stay out of avalanche terrain. Well, they still could be a problem. So March and early April came, and things eventually began to settle down, and we kind of settled into a more normal routine of storms. And the healing of that layer, it did happen. It just took time. And so what we were doing, we were just out there digging really deep holes in the snow, looking at the layer. But we were also just kind of watching and waiting and looking around with good visibility finally for the first time in well over a month. We could just look around and see, the biggest indicator of avalanches are other avalanches. And so we're just trying to track to see if anything is happening still. But we went through this period of uncertainty with the warm temperatures, and eventually things did settle out, and we were able to get out there and ski. So do a little video together.
Soy la del gallo que gana, mi suerte nació en Boca Chica y se perdió en la mirada de un capitán y un timón. Cartagena está en su sangre, en su color y su voz. No va por su suerte, espera por su gallo vencedor.
This is the Jim Hill avalanche path here. You can see it in the light shot. It just looks like a ski run. And there's West Camp over there.
Se enciende el pueblo en la tarde y en las escuelas se siente el miedo que está presente y la gente a todo pulmón. Son los gallos los que traen la esperanza entre la gente que no ha tenido ni tiene, que solo pide ilusión. Donde
So come late March, everything in the Stewart Range was pretty filled in. I went out there and camped with a couple of friends for a birthday trip for a few nights in Mountaineer Creek, and we stumbled across a lot of big debris piles. And this tree here was one of the bigger ones that I've seen that got knocked over during this avalanche cycle. But things were settled out. We found this really nice meadow, and we just camped right on the debris because we had a good view, and it was kind of wild. So where are we now? We're sitting at about 125% of average. Mission Ridge is a little below, but temperatures have stayed cold, and we've still got a lot of snow up there. To have this much snow like up on Wedge Mountain right near town here is pretty substantial for this time of year. And inevitably we'll go through a heat wave, and it seems like that's just starting right now. So the question on a lot of our minds are we going to see this deep persistent slab wake up again as in the form of a wet slab? Or are we going to see more glide slabs? It sure seems like we could see some of those. And here's a kind of an interesting graphic that I stole from a prominent ski mountaineer, Lil Skoog. And so we're basically heading towards bush season, where we're looking at a lack of freeze. The snowpack's finally going to start to melt down and transition from cooler, drier snow to larger grained wet snow. So we're going into that now. And that's pretty much all I got. I just want to say thanks so much for listening, all of you that are still here. And thanks so much to, the folks that I work with at NWAC and everyone else around here. And thanks for your observations. It's greatly appreciated. Really enjoy. And I'm fortunate to do what I do. So thanks.
Thanks, Matt. Great videos. I noticed John, my partner, is in one of them. So folks, if you have questions, this is a great time to chat them or type them into the chat comments. And we have time for a couple. And I know there was a question. Let me scroll and find it. Okay, so Kirk had a question when you were talking about the Wellington Avalanche. Says, how does that February 12th through 22nd time period compare to conditions / snowfall that triggered the Wellington Avalanche? Do you know?
Well, that's a good one. Leading into the Atmospheric River event of the 21st to the 23rd of February this year, I was reading up on that, basically trying to get my hands on anything I could find. And what it sounded like was a fairly similar scenario, actually, where they had gone through some type of a high elevation rain event that formed a crust on the surface earlier in the winter, and then went through a cold, dry period, and then settled into like this steady but kind of cold, snowy period. And then during when that avalanche happened at Wellington in 1910, it was a slow warm up. So it may have been fairly similar, but it's hard to say exactly what the week later was. Yeah, it's a good question.
All right, we got a question from Scott asking, what is the largest avalanche ever recorded?
Oh, that's a good one. Well, in historic times of I should say recent history that's well documented, there was an avalanche that came off Mount Huascarán down in Peru that wiped out a village. And I don't know how many people died. I think somewhere in the category of 1,000. Yeah, I actually went and had a look at that site when I was traveling down in Peru a number of years ago. It's all just abandoned. They didn't build back in that site.
Yeah. Okay, so James has a question of what causes the plastic beads looking layer between layers.
The plastic bead looking layers.
Yeah, James, if you want to type in the chat, maybe describe a little bit more what you're talking about. And while we're waiting for that, Matt, there's a question for you of where you're skiing this weekend.
No, I don't have plans yet. It's actually going to be really, it looks really warm. It might actually be a good weekend to kind of let the mountains do their thing and shed, and maybe float down the river. Stella says go mountain biking. Yeah, the flowers are blooming. You know, this is like a really big warm up we have coming. I don't know if it's worth trying to go ski in the situation we have. I mean, I'm working, so I'm going to be out there looking around, but I don't have faith that it's going to be great or very safe in a lot of places.
So in terms of the bead looking layer, Harlan is wondering if James is talking about grapple.
Oh, he could be. I guess I'll speak to grapple because that makes sense. Yeah, if you're seeing grapple, what that is it's formed as precipitation is falling from the atmosphere, and super cool water vapor droplets hit whatever precipitation particle is falling and freeze instantly onto it. And that slowly builds over time, kind of like hail does. And if you look closely at a lot of grapple, it'll have this shape. It's kind of like a diamond where it's got a wedge shaped like that at the bottom and maybe has like a little cap on it. And I think that's just because of the way that it falls and the way the vapor freezes onto it from air to a solid. And then once it's in the snowpack there, then it may just be sitting around and it maybe look like little marbles, and they can persist for a long time. And we have had some grapple layers just over the past few weeks, and avalanches that have run on them too.
So James chatted in and said he did a mountaineer training on avalanches. They're cut a trench and there was a layer that looked like plastic beads that just ran out of the layer.
That sounds kind of like grapple. Yeah.
Cool.
Yeah, they're really loose. Yeah, they'll often just like run downhill like sand or something like that.
So you're getting lots of thank yous, doing great job, great presentation. Wanted to share that with you. And then Matt, you talked about how your folks are thinking about how that weak layer might be awakened this spring. Are there things, I mean, you talked about how it's gonna be warm this weekend, but what could people be looking out for as they continue to ski this spring and not get caught in those big avalanches maybe to come?
Yeah, well, you know, in talking about deep persistent slabs, you know, one of the things I mentioned is that they're pretty tricky to deal with and pretty tricky to forecast because the layers are so deep and there's a lot of uncertainty that comes along with that. And then, you know, another layer of uncertainty for us is when the snowpack begins to change from dry snow to wet snow. What happens there is water will be dripping through the snowpack, and it may hit a layer and it may just sit on that layer as it forms like a boundary, or it may run through the layer. And so figuring out exactly when water is going to get down to that weak layer is a really difficult thing to do, especially on a wider range. If you're just looking at one slope, it may be like, maybe that's possible, but it's a very difficult thing. So really, numerous days of above freezing temperatures, like at night, or when we start to think about that. Like if you're out there and you just, there's no crust first thing in the morning, it didn't really get that cold last night, you step on the snow surface, maybe you sink in up to your knee, stuff like that in really heavy, wet, saturated snow, that's the scenario where you just don't want to be on any steep slope.
Right on, Matt. Well, thank you so much for participating in this virtual world with us and sharing all of your knowledge. yeah, really appreciate it. And thank you to everybody who tuned in and participated, asked questions. Yeah, if you all are interested in learning more about WRI and future programs coming, please check our website. Our calendar is the best thing. Follow us on social media, sign up for our e-newsletter, and also keep checking the Northwest Avalanche Center. They're still forecasting, and I think you're almost done, right?
Yeah, we're still putting out daily forecasts through this weekend, and then it'll that's all we got. Well, I think we're going to be doing conditions updates through the month of April.
Cool.
So yeah, definitely keep checking. And if you're out there and you see something interesting, another thing that I should mention is if you see other avalanches, and that's obviously one of the big telltales that you could trigger more avalanches or other ones could run. And so that's something to keep in mind. And our observation page will just continue be up and running. So definitely continue to use that, you guys. And yeah, we're kind of just crowdsourcing information through the spring as we stop forecasting.
Great. Well, thanks, Matt. Hope you have a great rest of your night. And yeah, thank you, everybody.
Thanks so much. Appreciate you having me.
Yeah.
Pleasure to be here.
Bye.
Bye.